Hi everyone, and welcome back to Maths and Physics with Mr. Simons. Alright, where we make maths simple and physics and we get you exam ready. Right? So today I'm looking at grade 11 Euclidean geometry, and I'm looking at the first theorem and the proof of that, which generally is tested. Can test you theorem 1a or theorem 1b. Right, so theorem 1a goes as follows, and sometimes this is asked as a short question where you just have to fill in the words that's missing. If a line is drawn from the center of a circle to the midpoint of a chord, then that line is perpendicular to the chord. Alright, so we're going to be proving this theorem, right, and I'm going to show you how we give it to you and what you're required to do. Right, midpoint chord. Given any circle with center O, so there's my center, and midpoint D of chord AB, required to prove, and we just write RTP, to prove that AB, this line from A to B, is perpendicular to OD, meaning here where these two lines meet, there must be a 90-degree angle formed. Right, so that's what we're required to prove, that's what they give us. So the key is here, they're giving us that AD is equal to TB. Right, so this chord drawn from the center splits the line AB into two equal sections. Right, now we have to prove that T1 equal T2 equal 90 degrees. Can prove that, I've proved that I've got two right angles, and therefore I can then use theorem of Pythagoras to solve and find length of sides. Right, can also in theory use trigonometry SOHCAHTOA. Right, but let's go look at the solution. Right, so the formal proof always starts with construction, right? So most of the drawings we're going to give you for theorems and so on that we have to prove, we have to construct something before we can do the proof. Right, so first we're going to draw OA and OB. You get 1 mark for that. So we're going to draw a line from O to A and a line from O to B. That way I've completed. You can see that there's a triangle AOD, there's a triangle POD, right? And that there, any line from center to circumference, from the center of the circle to circumference, they are called a radii. So I can say in triangle AOD and triangle POD, AO equal PO. So AO equal PO, they are referred to as a radii. So they must be the same length. Alright. Then given to me from T to A, see that red stroke there, and from T to B, that red stroke there, means that TA equal TB. So TA equal TB, that is given. Right, then we have this line in the center here, OD, that belongs to both triangles, AOD and POD. So OD is common. Alright, so therefore we can now say that triangle AOD is congruent to triangle POD. My reason, side, side, side. Right? So, proving that they are congruent now, I've proved that this is exactly the same as that. Meaning, the angles here, angle A should be equal to angle P. T1 should be equal to T2. Angle O there on the top must equal the other angle O. Right, so when we say triangles are congruent, their sides are the same and their angles are exactly the same. They're exact duplicates of each other. Right, but if you look at T1 and T2, they are on a straight line. So therefore, angles formed on a straight line, I assume you remember from grade 8 and 9, always add up to 180 degrees, right? So I can say T1 plus T2, T1 plus T2 equal 180, angles on a straight line, right? But T1 equals T2 because we've proven that they are congruent. Therefore, we can say it's 180 divided by 2 because we have two angles that are the same size, but the two angles also add up to 180. Right? So 180 divided by 2 then gives me 90 degrees. So T1 equal 90 and T2 equal 90. Right? And if they're 90 degrees, then it means this line OD meets up with this line AB, forming 90-degree angles, therefore they are perpendicular, so therefore OD perpendicular to AB. So that's, in short, is just the formal proof of Theorem 1A. In the next video, I will do the formal proof of Theorem 1B. Alright, so in exam we can ask you 1A or we can test 1B. It's one of the theorems you need to know. What your Theorem 2, angle at center, is 2 times the angle at circumference. What the Theorem 5 that says the opposite angles in a cyclic quad are supplementary. Right, what the tan chord theorem. Right, so those are the ones we test from grade 11 in grade 11 as well as in grade 12. Right, one of them must be tested. Right, now you have to continue practicing. My maths teacher back in the day, Mr. von Schaefer, always said, go do a proof over about 12 times. That way it sticks in your head and you know what to do. Right, so put in the effort. God bless. Bye.